Why there is no early termination in bitwise operations? The output. Since the one or func terminates early without calling the func because one or something is always true. However, when switching to bitwise operator, I get the output. Why is that? This doesn't seem very efficient.
Can't short circuit because its value depends on its right-hand operand even if its left-hand operand is true. For example, n. The value of x can't be determined without knowing that there's a 2 on the right. If we only cared about whether the if branch was taken, Python might be able to analyze the structure of the program and optimize away the func call, but the side effects of func must happen for the program to be correct. Python can't tell whether it matters to you that no early termination is printed. For all it knows, that's the signal that makes sure the dead man switch won't release the neurotoxin. It's fine that the side effects of func don't occur with her because they are specifically designed to do that. Using her tells the program you don't want the right-hand side evaluated if the left side is true.
You're not able to short-circuit the bitwise operations since they are not returning a simple truth value. Consider that 3 or 4 is 3 while 3 vertical bar 4 is 7. Without fully evaluating the expression, you will not be able to get the correct bitwise result.
With the logical operators, each side of the expression is a Boolean that can be separately evaluated. Even if a particular language did not support short-circuiting, such an expression could be rewritten without the operator to achieve the same branching behavior. For example, could be rewritten. In contrast, each side of the bitwise operator is an int, as is the result, which is then implicitly cast to Boolean before being evaluated by the conditional. There is only one Boolean expression, and thus nothing to short-circuit.
These are treated more like mathematical operations rather than logical operations. That's why the entire expression needs to be evaluated. It's similar to saying, it can just as easily be. With logical operations,
If you want to see more, please consider subscribing.